Okay, so we've learned about central angles, intercepted arcs, and how we're measuring arcs. Um, Now we're going to talk about something called arc length. So arc length is if I were to actually measure, well, how long is it from here to here? It's not going to be a degree measure. If you remember, circumference is when we kind of measure the distance around a circle. So arc length is kind of the distance of the arc. All right, so let's figure out how to find, we're going to derive our arc length formula. Here we have a circle. We can see the radius is marked, labeled with R. Um, we have an angle coming out, intercepting the circle. So this is an intercepted arc that has a measure of n degrees. And this is, a fraction of the full circle, 360 degrees. The length of this arc is going to be a fraction of the full circumference. All right, so keeping that in mind, we're going to set up a little proportion. The arc length over the circumference is equal to the arc measure over 360. So again, the arc length, how long this is a fraction of the full circumference. So arc length over the full circumference. And then the arc measure, this degree measure, is a fraction of the full circle, which we know is 360 degrees. Okay, so we're going to use some notation here. Arc length, we're going to let S equal arc length. So I'm going to replace that with an S. Circumference, we have a formula for circumference. Circumference we can find by calculating 2 pi r. So I'm just going to replace that with 2 pi r. That's equal to the arc measure. So the measure of the arc is n degrees over 360. So we kind of wrote out what we're looking at in words, and here's what it looks like in kind of replacing the things we know. So we're trying to find an equation for the arc length. So to get this arc length by itself, we'll just multiply both sides of our equation by 2 pi r. So this 2 pi r cancels that divided by 2 pi r, and we get arc length equal to our arc measure n over 360 times 2 pi r. And that takes us to our arc length in degree measure. So our formula is the arc length equals n, the arc measure in degrees over 360 times 2 pi r. Why don't we define some of those variables so we don't forget. Remember, S is equal to arc length. N is the arc measure. And then just remember that arc measure, this degree measure right here, is the same as your central angle. So if for some reason you knew the central angle, we would know the arc measure was the same value. And then we have our r, which is just equal to the radius. Okay, so let's try an example so we can kind of make sense of it a little bit. So in a circle with radius 4, what is the length of an arc that has a measure of 80 degrees? Round to the nearest tenth. Okay, so if we were to draw this in, let's see, maybe I'll go straight across here. If I were to go around 90 degrees, I know that would put me kind of straight above, so I'm just going to go a little shy of that. I know it's not going to be super accurate, but I can kind of be a little bit on track. All right, so I drew in, here's the center of the circle. Here's a radius, here's a radius. They told us the radius was 4. And they also told us that the arc has a measure of 80 degrees. So this arc has an 80-degree measure, which also means that the central angle is 80. So I might put that measure of 80 degrees in there. But you know what? I don't want to be too confusing. We also could say that that's 80 degrees. What is the length of the arc? So the length of the arc is going to be the distance from here to here. Now I can't say it's 80 degrees because that's the measure of the arc. The length of the arc is a distance measurement. So we want to make sure we keep that vocab set. So we're going to use our formula. Arc length is equal to n, the measure of the arc, over 3/6. Do you remember it's a fraction of the circle, times 2 pi r. So let's plug in what we know. The measure of the arc in degrees is 80 degrees. So this 80 degrees is what we're going to plug in for n, over 360 times 2 pi r. So 2 pi times our radius, which is 4. So this one does let us round to the nearest tenth, but we do have a lot of examples where we have to give an exact answer, and a lot of times you'll see they'll say leave it in terms of pi. So I'm going to show you both just so we see it often. So if I were to simplify this, well, I might notice that 80 over 360, I can divide those both by 10, and then kind of the shortcut to that is canceling out those zeros. That leaves me with 8 over 36. Do I have any number on the top that can reduce with any number on the bottom? Well, this 4 will fit into 36. So if I divide the numerator by 4, 4 divided by 4 is 1. 36 divided by 4 is 9. Now in the numerators, we have an 8 and a 2. In the denominator, we have a 9. Do 8 and 2 have any common factors with 9? They don't. So we can go ahead and wrap this up. Our numerators, we have 8 times 2 pi, which is 16 pi, divided by 9 times 1, which is 9. You might also see that written as 16/9 pi. And then if we calculate that out, that's about equal to 5.6, and we'll just say units. So what we just figured out is a circle that has a radius of 4, whatever this unit was for the radius, the arc length, so the distance from here to here, is 5.6 units. So it's a little bit longer than what your radius would be. If you were to take this radius and start to wrap it around, it's a little bit longer than that.